This is going to be a long one, so I may stutter, but this is identifying, predicting the products of balance and balancing equations. So the first, so you have to figure out what you're doing first, what kind of problem it is. So the first thing I look at is, are one of these two composed of only a single element? If it's not, then the only thing that it can be is double replacement. So if this was like Na and this was SrCl, then it could be a single replacement because the Cl could go from there to there, and then there would be nothing here and something over here on this side. If it was only composed of carbon, hydrogen, and oxygen, this would be like CHO or CH plus O, O2, be CH something plus O2, then you would know that it's a combustion reaction. And if it's two singles, then it's most likely a combination reaction. I'm pretty sure if it's two singles, it'll always be a combination reaction. So two singles, combination, a single and a double, or a single and a triple could be combustion. If it's a triple and a single, like CHO plus O2, it'll be combustion. If it's a double and a single, it could be single replacement. And since this one does not have a single in it anywhere, it has to be double replacement, because the only thing, you can't combine all those together and make a coherent thing. So, but if you tried to replace them, you'd replace one on both sides. So this getting replaced would mean that gets replaced. So it means it's double replacement. Double replacement. Those are really ugly arrows. I'm gonna erase this real quick. My ugly arrows have been erased and replaced with a bad O. So, now that you know that it's double replacement, you know that this side, it's going to be split off here, and everything on this side is going to get transferred over onto this side, and the same thing. So, it'll be NaCl plus SrSO4. Now you have to check that the charges match up. Like earlier when you were given the name and you have to make the formula, you have to balance the charges of it. So it might be balanced already, or you might have to balance it yourself. So Na is 1A, it's positive 1. Cl, 7A, it's negative 1. So that one's good. Sr, pretty sure that's like strontium or something. Strontium, there it is. 2A, positive 2. SO4 is a polyatomic ion. SO4, 2 minus. So positive 2 and negative 2. The 2 on these sides are good. We don't have to put any smaller numbers. What I was checking for is, do we have to put any smaller numbers? We may have to put some bigger numbers, though. So then I count out on each side. So we have Na, we have 2 on this side. S, we have 1. O, we have 4. O, we have 4. Sr, we have 1. Chlorine, we have 2. And then I'll do it in the same order, like this same order on this side. So Na, this side we have 1. S, we have 1. S, we have 1. O, we have 4. Sr, we have 1. And chlorine, we have 1. So, then I circle what is different. So on this side and this side, it's 1, 4, 1 in the middle, 1, 4, 1, and the 2 on the outside are different. So, then I start multiplying. Sometimes it takes a lot of steps, sometimes it only takes a few. So, first I have to multiply. You can't multiply a little 1 in the middle. You have to multiply the whole thing by something. So, I'm going to choose to focus on the Na and turn the Na from 1 into 2. Consequently, turning the Cl from 1 into 2. But first I've got to do it. So I'll put a 2. So it'll be 2, 1. Since everything else belongs to this thing and I'm not multiplying that by anything, it's not changing. So 2, 1, 4. Cl is also getting multiplied by 2, so 2. Then I take a look. 2, 1, 4, 1, 2. 2, 1, 4, 1, 2. That's what I'm saying. Sometimes it takes many, sometimes it only takes a few. That only took one step and only one multiplication. So you have to rewrite it. Na2SO4 plus SrCl2 over 2. 2 NaCl plus SrO4. Okay, that is it for that one. And that was a double replacement reaction. Took this, moved it over there, took that, did the same thing. First two stayed where they were. And luckily I didn't have to do any charge swapping in there, but sometimes you may have to. It's just the way it works. And it's the same thing, like if this had a 2, like a positive 2 charge, and that had it still had a -1 charge, you would move the 1 down there and the 2 over here. So instead of NaCl, it would be NaCl2. But that's not how it worked out. So we're lucky. But that would be the whole answer. So now we're on to C3H8 plus O2. So, this, when you only have carbon, hydrogen, and oxygen, your first instinct should be that's combustion. So, if it's combustion, that means the products are composed of CO2 and H2O. How much, we don't know, but we can find that out. So then I tally it up. So C, I have 3 on this side. H, I have 8. O, I have 2. C on this side, C is 1. O, make sure that whenever you're multiplying, you do this oxygen and this one. So, wait, I forgot. Hold on a minute. I'll be back in just... Got to do it in order. H is in the middle. H is in the middle. 2, 2. Back to what I was saying. There's O, and there has to be 3. So, 3. So, the first thing I'm going to do, everything is different. First, I'm going to try and change the H's to be the same. So I'm going to take this 2 and I'm going to multiply it by 4, consequently multiplying the O by 4. So, this would become 8. C stays 1. O, so now we have 4 oxygen plus 2 would be 6. So luckily it's still even, which is really good. So now I need to, so that's the same, it's good. 6, I'll leave that for later because luckily this oxygen is by itself, and as long as you have an even number for oxygen, you can multiply this by a number to get you an even amount of oxygen on this side, as long as the oxygen on this side is even. So next I'm going to change the carbon. So I need to get it to 3, multiply this by 3. So carbon, it'd be 3 carbon. So then it's 3 times 2 is 6. 6 plus 4 is 10 oxygen, still 8 hydrogen. And then, so 3, 8, 3, 8, 3, 8. Now all I have to do is multiply this oxygen by 5. 2 times 5 gives 10, so 3, 8, 10. 3, 8, 10. So C3H8 plus 5O2 goes to, I'm going to drop it down a little bit, 3 CO2 plus 4 H2O. And she might ask you to label it combustion. Boom. Last one. So, since it wasn't as easy to like just CHO their combustion, now we have to decide, is there a single, is there a double, and then what are those elements? So, single, yes, bromine. There are 2 bromine. So, 2 bromine and Ki, which is a double. So, because you have a single and a double, one will change to the other. This one, it'll become BRI, and then just plus K. Also, make sure you note that some, like if this was a gas, like if this was Br and like